Hello everyone, today we are going to start with the chapter number 4, atomic structure and chemical bonding. So what does this mean? Let me give you an introduction. So this concept of this atom originated from the ancient Greek philosopher Democritus. So an ancient Greek philosopher who studied the nature of the matter and basic constituents of all substances. And then we have John Dalton in 1808. He proposed a theory of atom known as the atomic theory. Dalton's original theory of the atomic has undergone modifications, but the principal aspects of the theory are still held valid, useful in study of chemistry. So, the postulates of Dalton's atomic theory are that matter consists of small indivisible particles called atoms. Then, atoms are neither created nor be destroyed. Atoms are the same element and are alike in every aspect and differ from the atom of all other elements. Atoms combine with other elements, in simple word, whole number of ratio forming compound atoms or molecules. An atom is the smallest unit of matter which takes place in a chemical reaction, and all chemical changes result from separation of combination atoms. Then modern atomic theory has conceded that most of the above postulates of Dalton's atomic theory and modern atomic theory are that Dalton states that atoms are indivisible and indestructible, but atoms are divisible and destructible. This is the modern theory, and the Dalton's theory also states that the atom is the smallest individual particles of an element, but the modern one states that the atoms are divisible, consisting of subatomic particles like electrons, protons and neutrons. Atoms are the same element, are alike in all respects and differ from atoms of other elements. This is the Dalton's atomic theory, and the modern state that atoms are the same element and may not be alike in all respects, as seen in case of isotopes, in which are atoms of the same number having the same atomic number of the different mass numbers. Now, the modern atomic theory, however, correlates with Dalton's theory. How? In the fact that atoms are the smallest unit of matter taking part in chemical reaction and is given as a compound, the relative number of the kind of atoms is a constant. Then discovery of the structure of atom, which is the electrons. So how were they found? The English physicist, which was William Crookes in 1878 discovered the cathode rays, which is the William Crookes found that when an electric discharge is passed through a tube containing a gas at low pressure, which is 0.01 millimeter of, so these blue rays are emitted from the negative plate, and these rays are called as cathode rays. So the scientist Sir J.J. Thomson in 1879 studied the characteristics and the constituents of the cathode ray. He also found that the cathode ray has the following characteristics, which is the travel in straight line from the cathode to anode, cast of a shadow of an object placed in that path, and then they are deflected by the magnetic and the electric field. They have kinetic energy. So the conclusion is that the cathode rays consist of negatively charged particles, now called as electrons, and atoms of all types of contain the same particle electron, and irrespective of the thing that how electrons are emitted, and these are identical. Since the atoms are electrically neutral and it must contain some particles which are positively charged, this led to the discovery of the protons, and mass of an electron is 1 upon 1837 of the mass of the hydrogen atom or proton, which is 9.107 into 10 minus 28 gram. So, and the charge of the electron is the unit negative charge, which is 1.602 into 10 divided by 10 upon minus 9 coulombs. Then this discovery of proton happened, which was from the scientist Goldstein. So the discovery of this positive ray emitted the anode, consisting of the positive charged particles, which are the protons. These are pre-photodisc and used as a cathode. The positive rays may be traveling in one direction opposite to the cathode ray. So the conclusion is that the positive rays consist of the positively charged particles, which led to the discovery of the protons. So the mass of the proton is 1837 times as heavy as the electron, which is 1.670 into 10 upon minus 24 gram. And the charge of an proton is unit positive charge, which is 1.602 into 10 upon minus 19 coulombs. So coulomb is the unit, so make sure you remember it. Then the discovery of the atomic nucleus. So this happened by the scientist Lord Rutherford in 1911. So the study of the atomic model and also discovery of the atomic nucleus happened here, and he directed alpha particles towards the metallic sheet, and the sources of the alpha particles are radium, metallic sheet, gold foil, and 1/1,000,000th of a centimeter, and alpha particles which are positively charged, and helium atoms containing 2 protons and 2 neutrons. Then the detection of the alpha particles was then observed, and conclusion drawn that the source of alpha conclusion was that an atom of a whole is relatively empty, and also that the alpha particles are passing very closely to the concentrated positive mass. It gets deflected through large angles, and if it approaches at right angle, it gets deflected through 360 Celsius. Then the discovery of the atomic nucleus happened. The postulates of the Rutherford atomic model, which is the matter in atom. So it is located in the space in the central called nucleus, which is associated with all the positive charge of an atom, while it remains while the remaining volume being very large empty space. Then since the atom is neutral, sufficient number of the electron must surround the nucleus to counterbalance the positive charge and revolve around the nucleus with the great velocity to confer the stability of the nuclear model of the atom. And then the backward of the Rutherford model, which was the Rutherford model of the atom of the electron revolved around the nucleus, and the attractive force of the positive charged nucleus will be balanced by the centrifugal force arising due to the rotation of the electrons. Then we have the Bohr's atomic model, which postulates of Bohr's atomic theory. So the electron revolves around the nucleus, which is at fixed orbits, and the integer, which is n, represents the various energy level 1 to 3 starting from the innermost. The level are designated as K, L, M, N. So as long as the electron rotates in one of the energy level, it neither loses nor absorbs energy. Then the scientist Bohr's model gave the preciseness of location and the model of the rotation electron around the nucleus. So discovery of the neutrons were the scientist James Chadwick in 1932. He discovered that he established that an atom consists of the subatomic particles, for example electrons and protons, and then the electrons are negligible mass, and hence the mass of an atom is concentrated in the nucleus. So therefore the atomic mass should be equal to the mass of the proton. So the conclusion was therefore that it proved that the nucleus of the atom are present particles which possesses no change but have the mass almost equal to that of the proton, and this confirmed the existence of the neutron. So this happened, and then the mass of the neutron is almost equal to the mass of proton. For instance, this is 1676 into 10 upon minus 24 gram. So these numerical values are really important, so you should learn them. And the charge of the neutron is carry no electric charge and are neutral. So these are neutral. Now we all were in the this formation and how they were discovered, the discovery of electrons and also atoms and protons, atomic nucleus, neutrons, all these happen. This was concluded in this video, and if you want me to explain furthermore, and make the part 2. Make sure to subscribe. I won't make this video lengthier than 10 minutes, so make sure to like so that I know you want part 2 of this. Till then, keep learning. Thank you. Subscribe. Bye.